Okay, we're starting on Unit 2 today, and in 2-1 we're starting with inductive reasoning. Now, we have several vocabulary words that we want to look at here at the beginning of the lesson. The first one is conjecture, and conjecture is an educated guess based on known information. Okay, an educated guess based on known information. And conjecturing is a line of reasoning called inductive reasoning, and that's our next vocabulary word. Inductive reasoning is using several specific situations to arrive at a conjecture, right? And so an example of inductive reasoning and conjecturing would be, like for example, if I look outside and I see lightning and I hear thunder, my conjecture would be that it's going to rain, okay? And so again, that's an educated guess based on the known information, right? And so since I have seen several specific situations where I've seen lightning and heard thunder, and typically that means that it's about to rain, then that's why I arrived at that particular conjecture. So that's kind of an example of using inductive reasoning to make a conjecture. Now, the next vocabulary word, counterexample. A counterexample is an example that shows the statement is false. Now, here's the key thing to remember about counterexample. It only takes one counterexample to show that a statement is false. Okay, so for example, let's say I make this statement: Coach Mason comes to work on time. Well, for that statement to really be true, that means every time I've come to work, then I've come to work on time. And so if there was one day 12 years ago that I was 5 minutes late, then that statement is not true anymore, and that day is the counterexample to show that that statement is false. So for a statement to be true, it must be true all the time, 100%. Okay? If it's not, then the counterexample would show that that statement is false. And a statement may have many counterexamples, but all it has to take is just one to show that the statement is false. So just remember, as we move into this unit, for a statement to be true, it must be true 100% of the time. All right, so keep that in mind as we move forward through the unit. Now, the directions for the type of problems that we're going to be looking at say, determine if the conjecture is true or false, and if it's false, then provide a counterexample. All right, and so here is the given information. All right, so this is what we're observing. Okay, so we're observing angle ABC and angle DEF are complementary. So that's what we know. That's the given information. That's what we are observing, right? That's the known information, in other words. These two angles are complementary, and of course we need to remember that that means that they add up to 90 degrees. They add up to 90 degrees. Okay? So we know that these two angles add up to 90 degrees. The given information is the facts. We know that these are the facts. Now, based on that, okay, that these two are complementary, somebody comes along and makes a conjecture, right? And the conjecture that they make is they come along and they say, oh, well, if they're complementary, then that means that they form a right angle. So we have to figure out, is that conjecture true or is it false? If it's true, it must be true all the time for every example, right, where these two are complementary. If it's false, I should be able to come up with a counterexample to show that the statement is false. In other words, if every time you have these two angles that are complementary, then they always form a right angle every time, then the statement is true. If I can have these two angles being complementary where they don't form a right angle, then it's false. All right, so let's take a look at it and see. So complementary, they add up to 90. So let's say I draw the two angles like this. So let's say I draw them like this. So I need angle ABC. So we'll make this angle ABC right here. And let's see. And let's say that this is 50 degrees. Well, if I make this 40 degrees, then I know they add up to 180, but here's the problem. I need angle DEF. This is angle CB something. You know what I mean? Even if I made this point D, then that still wouldn't be DEF. You see what I mean? And so, yes, these two do form a right angle, but I can't even make this angle DEF. So since these are three separate letters, then DEF has got to be over here away from this somewhere, right? And so, like, even if I made this point D, which I could, then if this is E, and then I would have to make another point for F, this would be 40. So yes, 50 and 40, they are complementary, but here's the deal. They don't form a right angle. They have to be adjacent. They have to share a common vertex in order to form a right angle here. And so this would be a false statement. So just because that they are complementary doesn't mean they have to form a right angle. They could be separated from each other. And as a matter of fact, with the way the letters are in this case, they would have to be separated from each other, right? And so when you are writing out a counterexample, you can create a drawing like this, or you could write out a statement. Okay, so in this case, I could say the angles are non-adjacent. And so since the angles, I could have two angles that are non-adjacent and still be complementary. If they're not adjacent together, they cannot form a right angle. So this is a counterexample. This drawing or this statement would be a counterexample to show that this statement is false. All right? Let's try another one. All right, so here's the next given information. It says angle ABC and angle CBD form a linear pair. So that's the information that we know to be true. These two form a linear pair. Okay, now here's the conjecture that ABC is congruent to angle CBD. All right, so let's see if that's going to be the case here. First of all, what do we know? What are the facts? Okay, these two form a linear pair. All right, and so if I were to make them form a linear pair, first of all, I know that linear pair from one side to another forms a straight line. Okay, so we learned that in Unit 1. And so if I have ABC coming here, so we'll make this one ABC, and this is point D to form angle CBD, then somebody comes along and looks at this and say, oh, well, if they form a linear pair, then they have to be congruent. Well, take a look at these two angles. From here to here, this one's less than 90. CBD, that one's more than 90. And so they're definitely not the same. They're not congruent. One's less than 90, one's more than 90. Okay? And so that right there would be your counterexample to show that this statement is false. Okay? As a matter of fact, the only way that they could be congruent is if this ray is perpendicular to this line. That would be the only way that you could draw it where they would be 90 on both sides and be the same. If you draw it any other way, they still form a linear pair, but they're not the same. And remember, it only takes one counterexample to show the statement is false. So again, when you're trying to figure out whether these are true or false, you got to think about all the scenarios. This is the given information. This is someone's conjecture. You have to see whether the conjecture is true or false. All right, here's the next one. Now, here's the given information. Angle 1 and angle 2 are complementary, and angle 1 and angle 3 are complementary. So these two add up to 90, and these two add up to 90. So angle 1 and angle 2 add up to 90. Angle 1 and angle 3 add up to 90. So somebody says, oh, here's my conjecture. Angle 2 and angle 3 have to be congruent. Okay, they got to be the same. Well, let's see if that's true by plugging in and see if we can find a counterexample. All right, so 1 and 2 are complementary. All right, so let's say that angle 1 is 10. Well, what would angle 2 have to be to add up to 90? 10 plus 80 makes 90. All right, so once again, if angle 1 is 10, what would angle 3 have to be to add up to 90? Well, angle 3 would also have to be 80. All right, so they are the same in this case. They're both 80. Well, let's see if we can find a counterexample. Let's try to change angle 1. Let's say angle 1 was 30 this time. What would 2 have to be? 60 to add up to 90? And if angle 1 is 30, then what would 3 have to be to add up to 90? 60. Still the same? Yes. What about if I change angle 1 to 75? What would angle 2 have to be to add up to 90? 15. And angle 1 still 75. What would angle 3 have to be? Still 15. And so it doesn't matter what you change angle 1 to. If they are both complementary to angle 1, they both have to be the same to make it add up to 90. All right? So there is no counterexample to this one, so this statement is actually true. Okay? This is a true statement. If 1 and 2 are complementary and 1 and 3 are complementary, then 2 or 3 have to be the same. There is no counterexample because it is a true statement. So you really kind of have to think through all scenarios here before you make a choice on this. You can't just rush to answer true or false. You've got to make sure that you're taking into account all scenarios because it only takes one counterexample in order to show that a statement is false. So keep that in mind. All right, so the next one. The conjecture that we have is segment AB is congruent to segment BC and is also congruent to segment AC. So you've got 3 segments and they're all the same length. That's the given information. So somebody comes along and says, oh, well, if that's the case, then A, B, and C are collinear. Remember from the last unit, collinear means all on the same line. So here's the question. If all 3 of these segments are the same length, do these 3 points have to be on the same line? All right, well, let's see if we can draw it. Okay, so number 1, let's see if we can draw them all on the same line, all collinear. So 1, 2, 3. So if they're collinear, they would have to be like this. All right? They would have to be like this. A, B, and C. A, B, and C. Okay? Now, here's the deal. Okay? Are these segments the same length? So let's say AB was 5. Let's say BC is 5. But AC would not be 5. AC would be 10. 5 plus 5. So this is not going to work, okay, because the given information is not true in this drawing. Remember, all 3 of these have to be the same. So if B is 5 and BC is 5, then AC also has to be 5. Well, really, the only way you could make that happen, if you've got AB being 5, okay, the only way that you could draw BC and AC also as 5 would be to make a triangle out of it here. So I would have to put C here, and that would be the only way that I could actually get them to be the same length, which means that there's no way that I can get them to line up one on top of, or line up all in a collinear fashion and still make the lengths the same. It wouldn't work. There's no way. And so what that means is that this statement, this conjecture is false. The conjecture is false. Why? Because they don't have to be collinear. As a matter of fact, you can't even draw them collinear. So there are many, many counterexamples to show that this one is false. And if you want to write it as words, you could say the segments can form a triangle. The segments could form a triangle. And that's actually number 5 on your quiz. So you might want to make a note of that you already have the answer to that particular one. All right, so remember, it's the conjecture that you're trying to tell if it's true or false, not the given. The given is a fact. It's the conjecture that you're trying to figure out whether that's going to be true or false. So take that information and make sure that you use it while you are working on your quiz. Remember, you already have the answer to number 5, and I will see you in class.